To help us analyze the question of the scoring, we're going to use the confusion matrix and the classification report. I will say the confusion matrix is one of my favorite names in all of machine learning. So here you go. From sklearn.metrics, import confusion matrix. And to help us understand this, we're also going to use the classification report so we can take both of those at once. And note that they're both in the metrics library, so they're dealing with metrics. Okay, so here's how you use it. You can just write confusion matrix, and then inside, you want to put in y test first and y prediction second. Okay, so it's a function and it takes two inputs, and let's talk about it in terms of the output. So let's press shift enter. Love it. Why do I love it? Okay, here's why. Because it did exactly what I mentioned. I guess 96.4 though and 0.3, well, whatever. What this reveals, okay, for the model to be 100% accurate, this would be 241 on the upper left diagonal, and the bottom right diagonal would actually be 9. Okay, so note that it's not. So what does the confusion matrix tell us? Depends on how you look at it. Okay, horizontally is I think the best way. Horizontally at the top, those are the ones. Those are the non-exoplanet stars. All 241 non-exoplanet stars were correctly predicted. Awesome. What the bottom row tells us is very glaring. It tells us that all 9 exoplanet stars were incorrectly predicted. So that's okay, look, I think it's kind of awesome in a way, only because it shows that in some cases machine learning models will pick the extreme because that was the best accuracy that it could find, right? It's simply looking for accuracy, which is 241 out of 250. I think I didn't like divide it correctly. Yeah, I didn't divide these correctly. They should be out of the totals, right? Yeah, sorry about that. Good job, model. 941 out of 250. Okay. And there we see the number. So this would be 250 minus 9, which is 241. I'll leave it the other way. It's a little fun to do it like that. Because it's 250 total cases, so my fault. And there you see the exact same score, right? So, and in many cases it could be different, right? And so, let's just look at the classification report to help us make sense of it, okay? So for classification report, do the same thing. Put in y test and y prediction. And also print it, because if you just run it, it tends not to look as good. It's designed to look better when you print it out. It's got a lot in it. And again, we'll talk about this by looking at what it does. So before I leave the confusion matrix behind, do note that the goal is to get everything on the diagonal. Okay, and you do not have that here. You have a 0 on the diagonal, you have all misses there. Okay. You can look at it vertically too, right? These would be the, how the vertical is almost like escaping me. If horizontal is case number 1, I guess vertical is the predictions of case 1. And so it got 241 out of 250 correct. That would predict non-exoplanets. But the prediction of exoplanets, it was 0 out of 250, so it got 0, right? Okay, so let's run the classification report. And this is exactly what the classification report reveals. Okay, so I don't know about these warnings, but there's a lot of good stuff in here. So first of all, it reveals to you scoring metrics that we're going to use. It reveals something called precision. And what you can see for precision, you're basically going on the verticals where like look at the vertical here, 241 out of 250. So of the predictions of 1, which in this case is no exoplanet, it was 96% correct. But but look, of the predictions of the zeros of all the exoplanets, they're all wrong. Now the recall is interesting, okay? The recall here indicates that, and I'm going to show you like a visual in a moment about what these precision and recall mean. But the recall indicates 100%, hey, you got all the non-exoplanet stars, but again, you failed. You did not get the exoplanet stars. And what's interesting is that the F1 score is the harmonic mean between them. It's not always the number in the middle. Okay, so before going further, let's take a look at a visual. I was trying to pull someone up. Here's a nice one from Wikipedia. Okay, so let's look at this a little bit carefully. All right, so here's a bunch of data. All these points are data. And then the left side of this data is correct. Okay, true positive means, hey, it was positive and it predicted it correctly. Okay, false negative, wait. It's confusing, isn't it, about the false negative and the true negative? And if you're ever confused about terminology, like, you can always look them up. I'm going to consult, I have out here I should know this, called the book that, I've mentioned a few times for this course. And in here it says false negative, incorrectly predicted is negative, right? And so true negative means it really is negative. Okay? So you have these four groupings, right? So, and in our case, again, let's assume that exoplanets are positives, right? So what you have here are very few exoplanets, and they're all going to be on this left side, okay? Okay, so let's go down to now what is precision and recall. So precision is basically saying, of the exoplanets that were predicted, how many were actually exoplanets, right? In this case, if you look at the picture, right, I mean, you can count the dots, doesn't really matter. But it'll be something like this. The data comes back and it says, hey, like here's the list of exoplanets. And right, there's a list, and the precision will tell you of that list, maybe like 75% are correct. They're indeed exoplanets, okay? But there is one big issue with that. It doesn't tell you about anything that's not on the list, right? So again, imagine that you have, in our case, right, there were 37. And so imagine that there are like one, okay? It predicted that there's one exoplanet and predicted correct. And you say, hey, 100% of my predictions were right. The precision was 100%. But it's only 1 out of 1. You miss most of the exoplanets. So that's where recall comes in. Recall looks at the number of true positives, right? Which in the example I gave would have been 1, but it's over that plus all the misses. So it would be like 1 out of 37, right? And so you can see that the recall basically tells you how many of the exoplanets you are getting, okay? And that's what I think you want for the scoring metric here. It's not really right or wrong in terms of choosing a scoring metric. But if the goal is to like identify, maybe that's not even the right phrasing. If the goal is to get as many exoplanets as possible, you want recall, okay? Because you might say like, hey, I've got a list of 150. I don't care if half of it's wrong. The point is I want to get those 75 exoplanets, okay? I'm not as concerned about like of the 32 here, like 30 are correct. I got a high precision. Maybe if you're wanting to confirm scientific research and actually identify them as such. But for just finding them, I think recall is good. And I think if you go back to the notebook, the F1 score is also good because it's a balance between the two. Now look, in this case, it's all zeros because it didn't predict any. But we can continue to use the classification report and or the confusion matrix to make adjustments. So here's the idea. What we want to do is we want to fine tune a model on a different scoring metric. That's the key, right? Because it's still going to predict the same thing. But let me show you first how to say, hey, like I want to get the recall score instead. Okay, well, we already built the model. So to use recall score, so from sklearn.model selection, import Right, it's not model selection. This is a metric now. Metrics. And then I'm going to import the recall score. Okay. And now to use it, okay, just a recall score. Now this is going to be really important, okay? You're supposed to put Y test and Y prediction, but by default, look, by default, it's counting the ones as what you're looking for. But in this case, it's actually the twos. So if I just leave it like this, I'm expecting to get a 1.0 result here. Right? It's got to be one of the two. Okay, so let's check that, press Shift Enter. You can see it gives the 1.0. But I actually want to do it on the twos. And so the way you account for that is you can change the positive label to 2, right? Okay, I should have gotten 0. Oh, because it said Y test, excuse me. Y prediction. And so let's switch it. I want to verify the difference. So now I still get the 1.0, but now if I do positive label equals 2, it should switch to the 0. And there you have it. So what we're going to do going forward is we're going to try to tune an XGBoost model to improve the recall score. However, before doing that, I just want to say I didn't randomize, give a random state, and it is conceivable that you got something different, right? So I could do this again, and it's not like a guarantee it would give the same, because there's a little randomness involved, that it would give the same accuracy score. But the point here, it's not like recall, like the model is the model. The point is that when we make changes to the model, we want to make changes to improve this score, okay? And so it's a combination here, not just of fine-tuning, but then of fine-tuning toward a score that's desirable and more revealing. And here's what I'll say in general before we do this. When you're considering different scoring metrics, the F1 score is a really nice one to use regardless. Maybe your data is a little imbalanced, it's going to be helpful. And there are some other nice scoring metrics as well, like the ROC or the AUC one. It's this area under the curve. It's like this characteristic. And so like accuracy, like it has limitations, which I just tried to reveal to you right here. Okay. So let's see what we can do, and I'll let this run one more time just to see if I can get a different score before clicking on the next video. And you can do that if I'm going to do it here. Runtime run after. It does run that one. So it runs everything after. And so let's see if I get anything different on a second pass. Okay.